Okay, the last topic of today is histograms. A histogram is a chart depicting a large collection of data with vertical bars. Across the bottom of the chart are the different ranges for the numbers, each range of the same size, and the height of each bar is the number of pieces of data in that range. Let us go to, watch this. I went through I had the data already. In 2012, MCLA offered quite a few classes, and there were different numbers of students in each class. There's 8, 19, and it's quite a long list of information. So if someone said, oh, how big are your classes? Well, in 2012, this is the answer. But how do we make sense of this? Well, we could say what the average was, but maybe they want more than just the average. Watch this. We highlight the whole thing, and we sort them from smallest to largest. Bang. And now we can count up the number in each range. Let's see, they go from 2 all the way up to 30. So let's make a chart. Let's make a chart where across the bottom we have ranges. What will our ranges be? Let's say 0 to 5, 5, no, can't have 5 twice, 6 to 10, well, why don't we call this 1 to 5? 1 to 5, 6 to 10, 11 to 15, 16 to 20, 21 to 25, and 26 to 30. So each one has exactly 5 numbers in it. You can't have, 20, 21 to 30 be all 1, because then this range 6 to 10 only has 5 numbers, and this would have 10 numbers in it. So no, you have to make sure that each range is of the same size. Now you could have gone you could have had 10 numbers in each, you could have had 2 numbers in each. Well, let's just see how many are in each. So 1 to 5, we have one class had 2 students. So this number is, there's one class that was in that range. 6 to 10, how many do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 classes had between 6 and 10. How many had 11 to 15? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. How many were between 16 and 20? 16 to 20 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 were between 16 and 20. How many were between 21 and 25? 1, 2, 3, 4, 5, 6, 7, 8. 8 were in that range. And how many were between 26 and 30? That was 1, 2, 3, 4 classes were that big. So it kind of helps to figure out what your numbers are first, so you can figure out how high to go. The biggest one is going to be 13, so maybe we can go 5, 10, 15. And then for 1 we go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And so for 1 we have a bar that is 1 high. And for 9 we have a bar that is 9 high. And for 13 we go all the way up to 13. Be nice, this would be a great time for graph paper. For 12 it's just a hair shorter than that. And for 8 we go out to, say, here. And for 4 we go out like that. And if you want to be fancy, I don't want to be that fancy, but we could color them in a little bit. Color in these bars. And so now when someone says, how big are the math classes at MCLA, we can say, and it doesn't hurt to put in a label on this, we can say enrollment numbers of MCLA math classes in 2012. And this gives you a picture. You say, well, it looks like, they're, between 11 and 20. Between 10 and 20. That is the lion's share. The lion's share is, but you do have a significant number of classes that are between 6 and 10, and a decent number of classes that are between 20 and 21 and 25. There's some classes that are as large as 30, but not too many, and they actually do run classes with, 5 or fewer students in them. This happens. Given a histogram, you can actually read off information off of it pretty easily. By looking at the heights, you could have gotten these numbers back again pretty easily. That is not so exciting. Whatever, this generally wouldn't be part of it because that information is now in the thing. I want you to be able to look at a histogram. I want you to be able to understand them. I want you to understand a few more things about it. One thing is, one of my goals for this course is to have you not be afraid of mathematics. And so if someone gives you a chart, what you want to do is first, how do you approach one of these things? First, look at the title. What is this information? What is it saying? If it doesn't have a title, it's not that great of a histogram. So you shouldn't feel intimidated if you're having trouble understanding something that's not very, very clear. Next, look at your labels on your axes. This probably should say number of students. I guess it sort of is listed up here, enrollment numbers, but still, these numbers are, what is 16? What, 16 cows, 16 frogs, 16 students. And this is the number of classes. So the fact that this one goes up to 13 tells us that there were 13 classes in 2012, math classes specifically, that were between 11 and 15 students. So, yes. And you can almost kind of see the median in here. You can almost see that more or less half of the students are over there, half of the classes are over there, half of the classes are over there. So somewhere in between 15 and, somewhere between, 15, give or take 3 or 4, that's the average. That's the median. So really read things really slowly. And there's a few different kinds of histograms I want you to know. If your histogram is shaped like this, a big lump in the middle that tapers off on either end, this is called a normal distribution. A normal distribution. Normal, mathematically normal. In real life, a lot of things come out this way. Versus if you have your histogram go straight across like this, or up and down a little bit, that's called a uniform distribution. And there's other ones. You could have a distribution that went like this. Okay, that's not uniform, that's not normal, that's just something else. And to end this, why don't we go and look at a few things I found. Here's a poster child of a uniform histogram. In fact, what's the title? The title is a uniform histogram. It's not a real data. It's someone made this for an example. But if you see, there's no big lump in the middle. That's, these are about as high as these. It's all more or less straight across. This, on the other hand, you have a whole lot in the middle and it tapers off quickly. This is more like that, what they call the bell curve of a normal distribution. What do we have here? Here's another one. Goes up and then down. What is this? Read the title. High temperatures in 2010. Okay, it's in centigrade, so it's not American, but so what? What is it saying? It says, what a shocker, the hottest days of the year, the hottest month of the year was August, immediately followed by July. September was pretty hot, and so was June. And that, springtime was moderate, fall was sort of moderate, and you want the really cold days, February and January. Pretty freaking cold. Ta-da! And this is real life. This is what nature does. Nature is high sometimes and low at other times. A lot of things in nature have normal distributions. This, you can't really look at this. This is how fast various cable services are, internet providers are. And you can't, there's no particular reason why they're in any particular order. But this is kind of normal. They're all pretty much the same. What is it? Okay, so Cablevision and Verizon, in fact, was it? Actual versus advertised. They actually were above 100%. They were actually providing internet faster than they said they were going to. And most of the other companies are giving you what they say. And what is this? Windstream and Quest are apparently offering, whenever they did this, offered less than they said that they were offering. Woohoo! And what is this? This is a list of what kind of degree you have and how likely are you to be unemployed in 2012. People who dropped out of high school had 12% unemployment. People who had an undergraduate degree were only 4.5% unemployment. The average was 6.8%. So, yay! And the average person, median weekly earnings. This is nice. This means half the people in 2012 were bringing home more than $815 a week, and half the people in 2012 were making less than $815 a week. And look at this. Source, Bureau of Labor Statistics. Hey, that's pretty nice. It's a government agency. Possibly more believable than something. They probably have a lot of data that they crunched down for this. And what is this? This is, now here's a slightly more suspicious graph. I mean, it's cool. You get some sort of normal distribution going on, and it's a number of callers, and this is what time of day it is. But the interesting thing is, if you notice calls, we have no idea what these numbers mean. Anytime you have a histogram where something is not labeled, be very, very suspicious. Is this millions of calls, dozens of calls? Who knows? But I just thought it was kind of cute, because if you look, these people, I'm sure it's probably some sort of call center that I stole this from. The Monday, they're making more calls on Monday, and then the people who come in to do phone calling, people who direct, what is it called, the people who call you up all the time? Anyway, they make a lot of calls on Monday when they're feeling a little refreshed, and then on Tuesday they make less, and Wednesday they make less, and Thursday they make less, and Friday even less. So they're just getting more and more tired through the week, is what I'm guessing. And then on Saturday you make a whole lot fewer calls. Probably there's fewer people in the office, or maybe people don't answer their phones. Sunday, even fewer people. I'm guessing that most people take the weekends off. But that's enough, and I want you to understand how to make a histogram, how to read a histogram, what to look for on a histogram, and to know the difference between a normal distribution and a uniform distribution.